Silence. So wait. Silence, please. So far we have discussed up to this one, right? Equivalence ratio. Okay. So we can calculate given the say percentage of excess here. From that we can calculate what will be the equivalence ratio. Clear? So that means they are related. One thing is that they are related. Okay. Another thing is that you see, try to see that the equivalence ratio, it depends on what basically air fuel ratio actual and air fuel air ratio actual and fuel air ratio stoichiometric. That is equivalence ratio. Right? Clear? Okay. Next is air fuel ratio is what basically which type of ratio? Is it gravimetric or volumetric? Is mass based or volume based? Mass based. Mass based. Air fuel ratio is mass ratio, right? Mass of air by mass of fuel. Okay. But say for example, in the last class, what I told is that that one thing you do not do that when I allow you in the class, it should not be. It is for you to attend the class, not to disturb or create disturbance to others. That should be the priority, isn't it? I am allowing you with the intention that you are actually attending the class. But in order you to attend the class, I am allowing the disturbance. So please keep that in mind. Okay, clear? That instruction was for you. Actually, you thought that you were privileged, so you have come with some attention. That should not be. You just go there. If you want to sit here, come first. Clear? Okay. Anything? Anyway. So the thing is that air fuel ratio is a mass ratio. Air fuel ratio is a mass ratio. Okay. Other thing is that in the last class, I tuned the parameter that was x, coefficient of the that is air, right? Coefficient of the air term. I changed from x to 1.1x, and immediately the equivalence ratio was changed to 1 by 1.1. So that means that 1.1 was what? Basically mole. Mole. That is the volume, right? But it directly came in the mass. Why? Can you tell me? Do you get the question first? Tell me. Oh, I miss taking the pen from my office. Table. At a bag as a bag as a. আমার টেবিল পেনটা আমার টেবিল নিচে অফিসে আমার রুমে আমি যেখানে বসি অফিস ওখানে থেকে একটা ব্যাগ আছে ব্যাগের মধ্যে পেন ছোট একটা ব্যাগ আছে hey so the question was that actually the question is this one. Try to understand. Say for example, this is a stoichiometric equation, chemical reaction. Stoichiometric means minimum. Stoichiometric means theoretical, minimum. Don't you write? Just दादू गल्प लिखते हो ना ঠাকুমার দাদু গল্প এটা ক্লাস 9 নিতে লাগে না So, when I told that it is theoretical, means what? Minimum. So there is no excess air, oxygen, and there is no unknown fluid. Okay. Now I change that from 2 to 2.2. 2 to 2.2. So what is the equivalence ratio? Yes, 2 to I change it from 2. Thank you. I changed it from 2 to 2.2. What will be the equivalence ratio?
1 by 2.2.
Huh?
1 by 2.2.
So if I change the coefficient, if I write, for example, I give you an equation that CH4 plus 2.2 O2 plus silence. Is equal to 4 CO2 plus 2 H2O, whatever, means there will be excess oxygen, etc. Right? So hydrogen and carbon coefficient will not change, definitely. You have to understand that. That means if I ask you to rewrite this equation with 2.2 instead of 2, where it will change? These two coefficients will not change because carbon and hydrogen I have not changed. Right? Not 4 CO2, it will be simply CO2. Okay, only what will change? There will be excess oxygen and there will be accordingly nitrogen. So what will be excess oxygen? So it was 2 initially. So 2 is consumed here. So it will be simply 0.2 O2. Only 0.2, that is extra. Plus what? Plus that is 2.2. Initially it was 7.52, that is 2 into 2 multiplied by 3.76, that is 7.52. Now it will be 2.2 multiplied by that. So 2.2 multiplied by 3.76 into. Clear? That is your equation. Now with this equation, if I ask you to calculate what is the equivalence ratio, what is the equivalence ratio for this? Means it is a 1 mark question set. What will you do? You will calculate. You will calculate this from the definition. So what will you do? Full equation. Then this equation. So what is the meaning of equivalence ratio? Fuel air ratio actual by fuel air ratio stoichiometric. Right? Now stoichiometric means what is? What is that? Fuel air ratio. What is the fuel air ratio? How to calculate that? Stoichiometric. Fuel air ratio. Fuel air ratio. Now what is the difference between fuel air ratio and air fuel ratio? What is the difference between fuel air ratio and air fuel ratio?
Mass base.
Reciprocal. Okay, reciprocal. So what is that? Mass flow rate of fuel by mass flow rate of air for stoichiometric condition. Right? That is this reaction. What is that? How to calculate? Mass means what? Mass means? Mass means total mass means what? Exactly. Number of moles
Into molar mass.
multiplied by
Molar mass.
molar mass. Exactly. So for fuel, what is the fuel here? Methane. Methane here. Here is the fuel. So that means number of moles of methane 10 multiplied by molecular weight of methane or molar mass of methane. Is it clear? That is the mass flow rate. Here you can give a flow rate, that is rate of change of that number of moles. Right? Rate of change of that number of moles. Divided by what? Air. What is the air? Oh, can't you see that? Is it visible properly? Not visible. I have to hide with bold. Okay. Now is it clear? Clear. Next is this one. Yeah. What is the formula of air? Is there any formula? Do you know the molecular weight of air? Since air is a mixture of gas, we can write in terms of mixture property. So basically, I will write for oxygen and for nitrogen. So that means here you see that is the coefficient external. Internal this is that is 4.76. So oxygen means what? Number of moles of oxygen multiplied by molecular weight of oxygen or molar mass of oxygen plus number of moles of nitrogen multiplied by molar mass of nitrogen. Clear? Whole multiplied by what? 2. Here it will be 2. Right? That means here, what is that? Here you can write this or you can skip this 2. Basically 2 is included here. Okay? That means 2 O2, that is here it is 2. So you can skip that. No problem. So N2 means what? NO2 means what?
Number of moles in oxygen.
Here it is what? Don't just note what is the value. That is the test, isn't it? That you will understand. It's not here. What is NO2? Number of moles of oxygen?
2.
Simply 2. What is MO2? You know. Right?
32.
32.
Yes, sir.
32. What is that? N2?
2 into 2.76.
2 multiplied by that. Clear? So both has 2 common. So you can take 2 common, otherwise you can keep that with N2. Next, what is M and O2? That is M of N2? 28. Roughly 28. Therefore, now this is stoichiometric. This is stoichiometric. Now what is actual? Can you tell me for this? What is that actual? Therefore, if I write what is actual, can I? Let me write here. A by A actual. What is that? For that reaction, what is that? Again, same thing. Mass of fuel by mass of air actual. Actual. Right? Actual. So what is that? What is the mass of fuel is changing? Is the mass of fuel changing? Is the mass of fuel changing? No or yes? No or yes? Am I asking a question like who will become the next chief minister? Like, is there any confusion? That what will be? What is the mass of fuel changing? Yes. How will change from here? This and this. Is there any change? So no is the answer, right? So therefore for this there will not be any change. So N of CH4 as it is 1 here, it is 1 here also, multiplied by molecular mass of CH4, right? That is clear? Okay. Next Next is here it is changing, right? Here it is changing. So what is that? Next is I will write n prime. Some prime I will give. That is for this reaction I am giving that as prime, right? A of O2 multiplied by molecular weight of O2 plus n prime of N2 multiplied by molecular mass of N2, right? Clear? Okay. Now this is not changing. Only this is changing, right? So can I write that this is equal to? Can I write that this is equal to? What is that? Here I have written 2.2. In that case 2.2. So this is equal to 2.2 divided by 2 multiplied by this one. This is simply 2.2. Whole thing is 2.2 and this is 2. Therefore, I can write that this is equal to 2.2 divided by 2 multiplied by that. Okay? So it is N2, NO2, MO2 plus NN2 multiplied by N. Clear? Therefore, this remains as N of CH4 as it is 1 there, N of CH4. Clear? Therefore, this is actual and this is theoretical. So, what is the value of equivalence ratio? What is that? F of A actual divided by F of A stoichiometric or theoretical. Clear? So what is that? Actual. So you see that here it is completely same.
Yes, sir.
Only thing is that here you have this extra thing. So all the thing will cancel here and here. Right? So only thing that will remain is here it is 2 by 2.2. That is 1 by 1.1. That is your equivalence ratio. Right? Just from the coefficient you can calculate the equivalence ratio. Right? Although this was mass ratio, and we started with the number of moles. Here I have changed the number of moles, but since mass is equal to number of moles multiplied by molecular mass, so molecular mass remaining same, they will cancel, and only mass ratio will be directly coming from volume ratio. Clear? So you don't have to multiply again with the molecular mass and calculate mass ratio of fuel and air, and from that you have to calculate. You don't need to do that. Simply by comparing these equations, the coefficient of oxygen, the air is changing, therefore that will be the coefficient, that is the ratio coming in the equivalence ratio. Is it clear? Is it clear to all? Oh. No, what is that? What is that? What is this? What is this? This is equal to, I am writing this one. Let me write. What is this? What is that? That is equal to 2.2. 2.2 A. 2.2 multiplied by what? That is 32. Right? Plus 3.76 into 28. This is this. And what is that? What is that? This is equal to simply 2 multiplied by 32 plus 3.76 into 28. So what is the ratio of this and this? This is equal to 2.2 divided by 2. ratio of this and this is equal to 2.2 by 2. Is it clear? Clear? So from the coefficients you can directly get the equivalence ratio. Clear? So instead of 2.2, if I would have given you 1.8, instead of 2.2, if I would have given you 1.8.
So in the actual it will be 2 32 plus.
That will cancel.
No, sir.
This part will cancel.
So in the actual it will be 2 and in the square.
In the actual it is 2.2. Actual 2.2. Actual equation 2.2. And theoretical it is 2. So the ratio will be, is it rich mixture or lean mixture? 2.2. Air is more, so it will be lean. More air means lean mixture. Right? Instead of 2.2, if I would have given you 1.8, so it will be deficiency of air, and in that case, what will be the equivalence ratio? 2 by 1.8. So it will be, sorry, 1.8 by 2. 1.8 by 2. So it will be
Less than 1. Less than 1.
sorry, here it is how much? 1 by 1.1. In that case, it will be basically 2 by 1.8. 2 by 1.8. So in that case, if it is 1.8, in that case it will be 2 by 1.8 and it will be more than 1. More than 1. Clear? So, are you conversant with this? That means, if the mole numbers are given in the equation or the equation is given in terms of excess air, then can you calculate the equivalence ratio directly? No? Or yes? Say 1 marks question, 3 marks question, 5 marks question, any question can be given. Right? Say if I ask you to write the chemical reaction, say for example, yes. পরীক্ষা কিন্তু কথা বলবো না বিষয়ে ঠিক আছে পাকা মোটা আমি কি পরীক্ষা দিন দেখতেছি সবাই এক্সামের রুমে okay say for example 1 marks question, simply 1 marks question I discussed that I give you excess air, percentage excess air, from that I ask you to calculate equivalence ratio. 1 marks question, what you will do? You will do this, simply calculate and show. Okay, it is short answer type question. If it is MCQ, then you don't just, you can do the rough in different page and show calculation directly here. So 3 marks question, then you will show in calculation, detailed calculation. If I ask you to write the equation also, that means I just give you that 110% excess air, what is the equivalence ratio, and write the chemical reaction. Then you have to write the chemical reaction, calculating the coefficients, etc. All this you have to show. So it may be 1 marks question, it may be 3 marks question, it may be 5 marks question. Is it clear how to do? Everything is clear? So can I erase? Okay. Okay. So here you see that the mole fraction. There is another concept that will come. Is mole fraction. Mole fraction means in a particular reaction, you have number of mole of a particular component and total number of moles. So in the mixture, you have total number of moles, and you have a particular constituent or compound or component for that number of moles is there. Say in the product you have CO2. So the number of mole of CO2 divided by total number of moles, that is called mole fraction. Yeah, mole fraction. So that is a concept. I think you know it, right? So, say for example, we will see that later also that there will be say partial that is concept of partial pressure distribution will come depending on the mole fraction. Okay. Okay. Next is combustion analysis. We will do combustion analysis of a plain hydrocarbon. Okay, this is the rigorous thing that we will do today. We will complete that. Combustion analysis of a plain hydrocarbon. Plain hydrocarbon means only carbon and hydrogen is there in this, and we are going to take a general hydrocarbon. Okay, so general hydrocarbon is that is the chemical formula. For example, say CnHn, where N and M are integers. Next is we write the chemical reaction that is with air. So that hydrocarbon is reacting with air and we are getting the products. Clear? Next is we are taking the, since we do not know what is the coefficient, so that is combustion analysis means what? We have taken, try to understand that we have taken a general hydrocarbon and we are going to understand what will be the coefficient of the required air for stoichiometric combustion. Right? Clear? So this is called forward combustion analysis. This is called combustion analysis means forward reaction. We can have a reverse reaction that is called exhaust gas analysis. So by knowing this, if I have to determine these things, then it is called combustion analysis forward. And if I know this and if I have to determine this, then it is called reverse combustion analysis or exhaust gas analysis. Clear? So here what we are trying to see is that what is the coefficient of A that is required, coefficient A that is required for complete combustion or theoretical combustion. Clear? So we know that what will be the products for complete reaction: CO2, H2O and N2. Right? There will not be any excess oxygen here because all the oxygen will be absorbed. All the oxygen will be absorbed by CO2 and H2O. Another thing is that even if it is say CH3OH, for example, methyl alcohol, then the oxygen here that will also be absorbed by this. Clear? In that case, the required oxygen here will be less. Clear? So for CH4, whatever coefficient will be, for CH3OH, the coefficient will be here less. Because some oxygen is already there in the compound or the hydrocarbon itself. So that oxygen, excess oxygen will be absorbed from the hydrocarbon, that is the fuel. Okay, the idea of complete reaction or complete combustion is that there will not be any excess oxygen in the products. Clear? So that is the complete reaction. That is without the coefficient, the reaction is this. The sole idea is to determine what are the coefficients. Is it clear first of all? That means when I write this equation, chemical reaction, without this coefficient A, this is just the structure of the reaction. Structure of the reaction, we do not know the coefficients. Now the next thing is, for this reaction, if it is complete reaction, theoretical reaction, what will be the coefficient that we have to determine based on mass conservation, mass balance. So how to do the mass balance? Simply balance of carbon atom, balance of hydrogen atom, balance of nitrogen, oxygen atom, balance of nitrogen. That's it. Is it clear? So from just number balance also you can do, because the molar mass or the atomic mass they are same on the reactant side as well as on the product side. Simply by number of atoms, because the number of atoms will be balanced, they will be preserved on the reactant side as well as in the product side. Only number of atom balance will do the job. Clear or not? Okay, so we determine A, that means we assign a value of A variable, and then B, then C, and this is what? This is known. Because if you know this is A and already this is nitrogen will be non-reactive, so it will be simply nitrogen atom will be 3.768, right? How many unknowns are there therefore here? 3. But how many equations we can form? 3. Balance of carbon, balance of hydrogen, and balance of oxygen. Right? From these 3 we can determine the 3 unknowns. Okay, is it clear? So that kind of question will come. That means given write the stoichiometric equation, right? Then you calculate the coefficient. Okay, now this is a exothermic reaction. So on the product side we have written thermal energy. That means what? Where from it is coming? Can you tell me? Although we are not solving conservation equation now, that means energy conservation now we are not solving, but we are writing deliberately to mean that this is exothermic reaction, and where from is it coming? Okay, where from is it coming? Any answer? Bank রাখা ছিল energy টা. Where from is it coming? Where from the energy is coming? Thermal energy. I told in the first class. Please you are there. Where from this thermal energy is coming? Liberated? Liberated from where? Chemical bond? Right? Some bonds are broken and some bonds are created. So during this time there is the energy interaction is happening in such a way that this is the algebraic sum of the energy that is released. That means here you see what is happening. Carbon hydrogen bomb, please listen. Here the carbon hydrogen bond will be broken and carbon oxygen bond will be created. Again carbon hydrogen bond is broken, hydrogen oxygen bond will be created. So during this time the algebraic sum of this bond energy released and bond energy absorbed is such that it is released. So algebraic sum of this, that means when the bond is broken, what happens? When the bond is broken, what happens? If I have to means break your head, what will I have to do? I have to slap. Means I am not means literally telling you. Means I have to slap. So what you will absorb that energy, right? That means when I have to break the bond, I have to apply energy. And when the bond is broken, energy is absorbed. When the bond is created, energy is released. So that happens everywhere. Here also, some bonds are broken and some new bonds are created. So during this time, the energy adjustment is such that effectively energy is released. So this is called exothermic reaction. Okay, is it clear? Next is 1 mole of hydrocarbon we are considering. Simply 1 mole we are considering. For this reaction we are not complicating it. Simply 1 mole of hydrocarbon we are considering, right? Next is the stoichiometric or theoretical combustion we are considering. That means complete combustion means what? What is the meaning? Complete combustion or theoretical combustion, what is the meaning? These things you have to be conversant. Otherwise things will remain ununderstood. What is the meaning of theoretical or stoichiometric? Minimum amount of air will be required. All the carbon will be converted to CO2. All the hydrogen will be converted to H2. I am repeatedly telling because first time you have to this repetition will be needed. Okay, clear? So that means all the oxygen will be converted to means absorbed in CO2 and H2. There will not be any excess oxygen. all the carbon is converted to CO2, all the hydrogen is converted to H2O. Okay, is it clear? That is theoretical. Next is there are carbon, hydrogen, oxygen and nitrogen atoms. Four types of elements are there as you can see. So four unknowns can be solved. Okay, now on mass balance, that means by using mass balance. Now nitrogen is already solved because nitrogen is non-reacting, isn't it? Isn't it? Nitrogen, since it is non-reacting, I can directly write that without solving. So although there are four types and four unknowns, but I can deliberately make this 3.76a here directly because without solving I can write it, isn't it? 3.76a I can directly write without any complication. Clear or not? Right? So the remaining there are three unknowns and three equations. Clear or not? So however here is considered fixed composition by volume. So it is a fixed composition by volume. That means within this bracket, this part will not change. Is it clear? Whatever I write, O2 plus 3.76 into this is fixed composition. So this within this bracket term that will not change. Clear? So fixed composition by volume of oxygen and nitrogen. Therefore, if the amount of oxygen is known, the amount of nitrogen is also known. If it is 1, then it is 3.76 of that times. If it is 2, then it will be 3.76 multiplied by 2. That means if oxygen is known, by default nitrogen is also known. Because it is a fixed composition. Isn't it? Clear? Clear or not? So, therefore, if the amount of oxygen is known, the amount of nitrogen is known by default from the known composition, that is 1 is to 3.76. Therefore, actually there are three unknowns only. Clear? So hydrocarbon is considered known here. We are considering now the hydrocarbon known, that is N and M are known. That means we will consider some value of N and M. For example, if we take say methane, then N is equal to how much? 1 and M is equal to 4. So that means if I take a general hydrocarbon, this is CnHm. But if it is some known hydrocarbon, accordingly N and M values are known. Therefore, we can go for solving the thing. Clear? Next again I write this. Next what we do? Solution of the unknown coefficients. So carbon balance. If I do carbon balance, then B is equal to N. Simply B is equal to N. Because it is N here, so B will be N. Simply. Next is from the number of hydrogen atom balance 2C. Here you see that it is 2C and here it is M. So 2C is equal to M, therefore C is equal to M by 2. Just balancing these we can get. And from the oxygen oxygen atom balance, so it is 2A is equal to 2B plus C. Clear? And already we have solved B and C, therefore we can solve A. B is equal to known. Known things I have given with green and unknown things I have given with red. So B is known, C is known, therefore A will be known. A is equal to N plus N by 4. Okay, is it clear? Is it clear to all? This type of problem may come. So you have to know it properly. Okay, therefore the balanced chemical reaction is, I can write this. So what I do? I replace all these red unknowns with the knowns. Next. Clear? Therefore we know ABC and just replace it. Clear? That is the reaction. Okay. Clear? Is it clear? So that means up to this. Is it clear? Okay. Next is air fuel ratio. How much time is there? 5 minutes. So air fuel ratio, can you calculate the air fuel ratio for this reaction? Can I calculate the air fuel ratio for this reaction? Air fuel ratio means mass of air by mass of fuel. So mass of air means total mass of this. and mass of fuel means this. Clear? So let us calculate that. The balanced chemical reaction, again I am rewriting that reaction in this page. Next, what we do? Air fuel ratio is the stoichiometric or theoretical air fuel ratio because considered combustion that is theoretical or stoichiometric. In the last page, I mentioned that was for the stoichiometric or theoretical combustion. Next is air by fuel, that is air mass of air by mass of fuel stoichiometric. So mass of air by mass of fuel. Now what is that? Air. That means whatever number of constituents are there, oxygen, nitrogen, etc., summation of that. So what is N? Molecular mass. What is N? Number of moles. Here is also fuel. So if you have many fuels, right? So I have written the general one with M and N, right? Is it clear? So mass is in terms of molecular mass multiplied by number of moles. So I can write this simply as earlier. That is, what is that? Mass, molar mass multiplied by number of moles for oxygen plus molar mass multiplied by number of moles for nitrogen divided by molar mass multiplied by number of moles for CnHn. Right? That is for fuel. So I can simply write this 32 for oxygen, 28 for nitrogen, and what is the molecular mass? N multiplied by. Now what is M for fuel? Sorry, what is N for fuel? 1. So simply molecular mass is coming, right? What is that? N Cn, that is 12 into N plus M hydrogen multiplied by 1 because atomic mass of hydrogen is 1 and atomic mass of carbon is 12. Okay, is it clear? So this is called CnHn. Clear or not? Is it clear? So simply that is your air fuel ratio. Clear? For example, if I take now methane. So what will be the value of N? 1. What will be the value of N? 4. So we can calculate the air fuel ratio just by replacing here N and M. Okay, is it clear? So we can rewrite the chemical reaction for methane and we can therefore that is the total reaction after rearranging, that means after re-evaluating 4 by 4 is equal to 1. So I have just recalculated this. Here I have written exactly by replacing M and N. After that I have calculated again and then rewrite. Clear? So what will be the air fuel ratio therefore? This is the air fuel ratio. What is the value? 17.16. Clear? Again I am asking the question finally. What is air fuel ratio? Is it volume ratio or mass ratio?
Mass ratio.
Thank you. For today, up to this, thank you. Absolutely, I will share.